Hello everyone. Today we will learn about Runge Kutta method. It is a fourth order approximation and a better approximation than Euler's method to solve ODEs. Let's start with the Taylor expansion. From Taylor expansion, let we have y of x about x is equal to xn. And we can say that y of xn plus h is equal to y of xn plus h y derivative plus h square by 2 y double derivative and so on. Here we can replace f of xn yn by y prime xn and the terms h square by 2 into double derivative of xn and so on. The higher terms containing h square values can be written as order of h square terms. We can construct a more strict integration method by making Euler-like child steps to midpoint of the interval and using then the values of both x and y at the midpoint to make the real steps across the interval. Runge Kutta method actually tells us more smaller the step size, the more accurate will be the solution. So we consider in Euler's method then x1 is equal to x0 plus h. But in this method we will consider x1 is equal to x0 plus h by 2, the half of the step size. So keeping it in our mind, we will declare first order Runge Kutta method and call it k1, and that is equal to h times f of x n y n. That is simply a Euler method. K2 is a h into kn plus half of step size and yn plus half of the k value calculated in the previous step. And the third order term k3 is equal to h times f of xn plus half of the step size and yn plus half of the k2 value calculated in the previous step. And the fourth order k term that can be written as h times f of xn plus h and yn plus k3. Remember here in the last term k4 we will calculate the step size, actual step size, that is h, and consider the previous calculated k3 in this step. And we can generalize this relation as yn plus 1 is equal to yn plus k by 6, k2 by 3 and plus k3 by 3 plus k4 by 6 plus order of the higher terms containing h5. Look at k1, there is only h raised to power 1, and in k2 we see that h multiplied by f of xn plus h. It means that h contain the previous k1 h also, and then we can say in k2 h will be the order of 2, and in k3 h will be the order of 3, and k4 h will be the order of 4, and so that's why we have next term order of 5. So as this method is fourth order approximation, so we can neglect the higher terms and only write yn plus 1 is equal to yn plus k1 by 6 plus k2 by 3 and plus k3 by 3 plus k4 by 6. And this is the method which we shall use to integrate first order ODEs. Students, here we have an example. I have already calculated in C program the fourth method, that y prime is equal to xy, where is equal to 1, y naught is equal to 1, and step size of 0.1. In previous example, we can compare the values with Euler's, improved Euler's, and actual values, and we can see clearly that this method is approaching the actual value more accurately as compared to Euler method and improved Euler's method. Y1 in Runge-Kutta method is equal to 1.11071 and actual value is equal to 1.110706. And we can see clearly from this picture more accurate than Euler's method and improved Euler's method. Your questions are welcome. Please feel free to write or inbox your comments, and stay at home, stay safe. Take care.